Hello, Mrs. Houston. We're doing our Regents review. This is question 11. Sunny purchases a new car for $29,873. The car depreciates 20% annually. Which expression can be used to determine the value of the car after T years? Okay, this is definitely one where, let's say it was open-ended. You might not have any idea, what should the expression look like. But luckily here, we have these four options in front of us. I think it's really important to take a look at the differences. And at a quick glance here, I can notice that they're very similar. The only thing that changes on each one is what is inside the parentheses. All right, we have 0.20, 20, 1 minus 0.20, and 1 plus 0.20. So that's a good thing to notice at the beginning. Let's go back to our problem. If we read it again, Sunny purchases a new car and the car depreciates, okay? That is an important vocabulary word there. That means, and you might know this, like as soon as you drive a car off the lot, the value starts to decrease. If you turned right around and tried to sell it back, they wouldn't give you the same amount. They'd take money off. So that's just what happens with cars. And especially if you have a car for a whole year, it's going to lose value. So depreciates means that the value goes down. Okay, so using that fact, there is an answer choice that we can eliminate. Which answer choice do you think we can eliminate? All right, I'm hoping that you were thinking number 4. That's what I was thinking, because this has addition in the middle. And if it's depreciating, the value is going down. It shouldn't be adding on value. Okay, the other important thing to know is that when you're writing a percentage in an exponential function, you have to convert to a decimal. All right, and to do that, you do 20 divided by 100. 20 divided by 100 will give you 0.20. That decimal moves 2 places. Okay, so 0.20. Now, if I know that, I can eliminate number 2. Because this 20 here, if we move 2 places the other way, is really 2,000%. Okay, not 20%. Another good way to think about it is, like if you think about money, whatever the amount of change is, because there's 100 pennies in a dollar. So 0.20, 20%. 0.05 is 5%, but 0.5, you really have to add the 0 on here. It would be like 50%, because that would be 50 cents. So this is, the difference between these two is something that, comes up a lot, and that's an important thing to think about. Okay, then the other thing is it's not, if it's depreciating, like the 1 is the original value. If I multiplied 29,873 times 1, it would still give me the same value. But then if I'm subtracting 0.20, we're taking 20% off, okay? So this is the correct answer, because you have to subtract that 20%. If it looked like number 1 with just one number in there, you would have to actually subtract this. 1 minus 0.20, or $1 minus 20 cents. Whoops, I don't want to write a 1. $1 minus 20 cents is 80 cents. Okay, so it would be either or. You could either write 1 minus 0.20, or you could write 0.80, because that's the answer you get when you subtract these two. So that eliminates choice 1, and we know that number 3 is our answer. All right, number 12. If f of x equals x squared plus 2x plus 1, and g of x equals 7x minus 5, for which values of x is f of x equal to g of x? All right, I've said it a couple times already, but remember, whoopsie, y equals saves lives. Here we go again, y equals, okay? we have two different functions, and we want to know when is f of x equal to g of x? When are these two functions equal? All right, so we're going to put them in, and we're going to take a look here. So go to y equals, clear out our old ones, and we're going to put in x squared plus 2x. And then we're going to put in 7x minus 5. Okay, just double check that I typed those correctly. Okay, pause it now if you haven't and put that into your calculator. And then what are we going to do to find out when they are equal? All right, hopefully you're thinking of going to the table, and I'm going to give you a quick heads up. When you look at all these answer choices, they are all whole numbers, which is nice because we know that our table, the x values, go by whole numbers. All right, I see -3, -2, so I'm going to go back a little bit here, and let me bring this onto the screen. Okay, so here is our table. We're looking for where are they equal. Give it a, something looks funny. I don't see any values that are equal. Let me go back. Maybe you guys noticed. Did I make a mistake? Oh, there's my mistake. Wow. Did you guys notice this when I was boxing that in? I forgot the +1. Whoopsie. Okay, so a good example here, I even make mistakes. If you start looking at your table and you don't see, like I was looking at -1, they're not the same. 6, they're not the same. You know, none of them, they were the same. And I was like, wait a minute, that's not what I got the last time I did it. So if that happens to you, go back and check. Make sure you type the right thing in. Doesn't mean you're doing the wrong strategy. I just skipped over that +1 there, so I had to go back and read that more carefully. +1. I think I was getting so excited talking about y equals saves lives. Okay. Now I'm going to double check again. That looks better. Okay, so let's go back to the table this time, and hopefully we find something here. All right, take a look. What do you think? All right, the nice part is we know exactly which numbers to go to, even if we couldn't find it. -1 and 6. Here's -1. Are the two y values the same? -6 I can't see, but -1 we already know is not an answer. -3, -2, the y values don't match up, but look at 2 and 3. Ah, here we go. When the y1 and the y2 are the same, that means that they're equal. So our answer is number 4.